Hello there everyone, good to see you on session Spring Cloud Stream Reactive tutorial. Reactive programming is a jargon we keep hearing now and then. Let it be front-end technology like Angular or back-end technology like Java or Spring. Agenda for this session is to understand what is reactive programming and how Spring integration supports reactive programming. If you are looking for imperative style of communication, please watch my first video of this series, of which link is present in the description. Alright then, let's understand what is reactive programming. Well, if I read out definition out of the book, reactive programming is about non-blocking applications that are asynchronous and event-driven and require small number of threads to scale. Wow, that's a lot new terms to digest. Let's break it down into smaller chunks. A key aspect of the definition is concept of back pressure, which is mechanism to ensure producers don't overwhelm consumers. That means receiving side is not forced to buffer arbitrary amount of data. So let's understand back pressure in the detail. Reactive stream specification supports publisher type, of which publishes items to subscriber. Subscribers consumes item when their on next method is called. When subscriber subscribes, it's given a subscription, which it can use to signal how many records it can handle. The last bit, the ability to specify exactly how many records a subscriber prepared to handle so the publisher can't overwhelm subscriber. This promotes stability. In the context of reactive programming, this flow control is called back pressure. There is a final interface processor which is simply bridge between publisher and subscriber. Reactive Stream supports two publisher specifications, Flux and Mono. Flux is the one which emits 0 to n items and Mono which emits single or no item. When you will use reactive programming is not a silver bullet to all. Will you start adding reactive programming to all communication? Of course not. Most common use case will be as soon as you conduct more data over the wire. As we move to the world of microservices or big data or long-lived session, for example WebSockets or server-sent event, then we'll start conducting more data over the wire, which will eventually saturate I/O buffers with API call. We spend more time doing I/O rather than performing business logic. Well, I/O isn't a problem in itself. So what's the problem? Remember traditional while loop which we use for reading data from input stream? Thread must wait until it reaches to end of the stream. This coupling of threads to I/O is unnecessary, as operating system had support for backgrounding I/O and notifying you when you should be involved for decades. And Java already incorporated this feature since Java 1.4 through NIO. Lots of projects like RxJava or Project Reactor seek to solve programming model that supports this new asynchronous reality. There is a common ground, and out of this common ground was born reactive stream specs, which this project supports and all other supports as well. Let's move to lab to see how to configure reactive streams for communication between two microservices. We'll be using RabbitMQ for messaging. I will be using Docker instance of RabbitMQ and command for this is present in the description. It takes some time to bring up this instance. Meanwhile, we'll write our reactive producer. Let's take help from Spring Starter project. Specify name P1, add dependency of CloudStream and Spring for RabbitMQ. For this demo, producer will create random strings and push to the message queue. Now let's write producer bean. As Spring Framework sees return type of supplier is Flux, it recognizes the difference in the programming style and works accordingly. Let's add a unique identifier to each tweet. And some delay to publish the message to queue. Now define the topic name where we have to publish these messages. So first property refers to the Spring Cloud function and second one the topic name. So processor in -0 is our topic where we want to publish our messages. Let's execute. Now as we go to exchanges, we can see processor in -0 and some messages are coming in this processor. Now let's write another microservice which consumes these messages. Again, we'll be taking help of Spring Starter project. The service name will be C1. Add same dependency of Cloud Stream and Spring for RabbitMQ. And write consumer. So we'll write consumer which will consume messages from processor -in-0 topic. That's all needed to configure a processor and consumer. So this pin will act as a processor and this pin will be consumer. Spring Framework looks at the return type of function and consumer and he will understand that he has to utilize reactive framework for consuming and publishing messages. Let's complete these methods. The processor will take string, append some string, and convert whatever tweet we are producing to uppercase. And consumer will just print out that. Now let's specify the binding properties in application.properties. Again, the first step will be define what are cloud functions present in our microservices. Then wire the topic, like take input from processor.in, convert it into uppercase, and put into processor-out topic, and sync or consumer processes messages from processor out-o and print out to the console. Let's execute consumer. Now, as we can see, the consumer is taking all the messages, converting into uppercase and printing over here. That's all for today's session. I have provided all the link in the description for the references using which I have created this tutorial. Thank you.